Now we will switch to English for the next roundtable, where there will be a discussion on which are the energy challenges that Europe is currently facing. And to do so, I would like to introduce and come up stage Jordi Gasset, European Projects Manager at the Kim BCM Foundation, that will introduce also the panelists for this roundtable. Thank you.
Hello everyone, and it is indeed an honor to present this first roundtable that we're going to discuss here, the main challenges in energy for the European context, and we're going to focus on especially on nuclear fusion opportunities both for climate change mitigation, renewable energy production, and also sustainability. So I think that it is an important topic to raise here, and we will be joined here with a very excellent panel of experts with a diverse expertise in the field of nuclear fusion, which I would like to introduce to all of you. So first of all, we have with us Ángel Ibarra. He's a technical director of the International Fusion Materials Irradiation Facility in IFMIF-DONES. He's joining us from Granada, and he will provide us with his experience mainly on the promotion and implementation of research facilities in the field of nuclear fusion. Next to him, we do have Yassid Ayyad. He is lead researcher at the IGFAE, the Instituto Galego de Física de Altas Energías. He's joining us from Santiago de Compostela, and he is a lead researcher in particle physics and also in advanced energy applications. And finally, we do have with us at the bottom of the screen, we do have Lorenzo Capisani. He is a policy officer at the Directorate General for Research and Development of the European Commission. So we thank you, all of you, for being here with us and being ready to have a very interesting discussion on the possibilities and opportunities posed by nuclear fusion to the European context. And without further ado, I would like to pose my first question to you, Ángel. And I think it is important for those members of the audience that might not be as familiar as others with nuclear fusion. If you could give us a bit of an explanation of what nuclear fusion is, how does it work, and also how it differs from other energy sources. So if you could give us a bit of a hint on that, on the opportunities and the benefits that we can gather from nuclear fusion, and also on the other side, what are the main challenges at the European level that we are facing in the current context? So I'll give you the floor, and you can give us and enlighten us a bit on nuclear fusion. Thank you, Ángel.
So thank you very much. First of all, good morning. Thank you very much for inviting me to join this meeting. And I'm sorry that it was not able for me to be in person there. I will try to explain a little bit what is nuclear fusion in a few words, but I'm not sure if it would be a little bit too long. Nuclear fusion is just the energy of the sun. It's the procedure that the stars use to produce energy. And in a few words, that means that we try to fuse together light ions to produce a heavier atom. And there is, in this process, there is a small difference of mass, and this mass is transformed in the shape of energy. The difficulty or the problem in the stars is very easy or relatively easy to produce this effect because the particles are put together due to the gravitational effects. But we try to reproduce the same effect in the Earth, and it is not so easy because to put the particles together, we need to provide energy to these particles in such a way that they can collide and they can interact between them. And this is not so easy in a controlled way. Along in the last decades, it has developed mainly two procedures in which this can be produced in the Earth. A first procedure is to maintain the particles at relatively high temperatures with high energy in the range of 100, 200 millions of centigrade degrees to maintain the particles, as I said, confined in a space using magnetic fields in such a way that the particles can be maintained in this area during relatively long periods of time, and then they have a probability to interact and to produce these fusion reactions. There is another alternative that is to make a small ball of the fuel that we want to use for these reactions, and to produce a compression of this ball by illuminating in all the directions with lasers or with any other procedure. And in this implosion process, it is possible to produce also a small burst of fusion reactions. These are the procedures that are presently being explored to produce a fusion reactor. It is usually we think that it is very difficult to build this. It is not so difficult to produce fusion reactions. To get fusion reactions can be made in almost any kind of laboratory because we only need to have an accelerator. The difficulty is to produce this in enough quantity and with energy gain. And this is the effort that is being developed in the last decades in the humanity, but especially in Europe, to produce, to build fusion reactors that allow us to produce electricity in this way. The main advantages of this method to produce energy is that you are able to produce a lot of energy. The energy density of the process is very high. Compared with nuclear fission, it does not produce radioactive products of long lifetime. The type of waste that these fusion reactions will produce are relatively limited. And it is the final advantage also is that, well, it does not produce CO2, of course, and also the fuel that it will be needed to produce these reactions is relatively abundant. I don't want to go into too much details, but at the end, the most feasible procedure right now, it only requires lithium, that is a material that is relatively abundant in the earth, and it can be extracted also from the sea water, and deuterium that is also relatively available, relatively abundant in the water, in the sea water. So the fuel for this type of reactions will be relatively abundant, and it is not so concentrated in a few areas of the Earth. So it is a type of energy, or it could be a type of energy very complementary to the other renewable energies, because it is not subject to the intermittence effects or to the availability of sun. It can be a high-density energy producer working 24 hours, without some of the impacts of nuclear fission. The difficulties or the problem is that it is not so easy to build these fusion reactors, and this is the effort that is being made in the world, and especially in Europe in the last, I would say, 60 or 70 years, to try to solve the technological challenges that this construction has. The main, today, at this moment in time, you know very well that it is being built, the ITER reactor, the ITER experiment in the south of France, in a collaboration with a lot of other countries in the world. That the key objective of this machine will be to demonstrate the scientific feasibility of control fusion reactions during relatively long periods of time, together with some of the key technology issues that needs to be solved. But this is not the only problem to be solved. Besides this, it is needed to demonstrate the full technological feasibility of the process. And to do this, it is needed to build, or in principle, we are planning to build a demonstration reactor, a demo, we call it demo, a demo reactor that will be able to produce electricity and to fully demonstrate the fuel cycle and all the key aspects of the fusion reaction. So this is, in a few words, the roadmap that Europe has for the development of fusion energy as an energy source, and the challenges that we have in front of us.
Okay, thank you very much, Ángel, and thank you for just bringing together all the information. I mean, I think it's quite complicated to put all the information about what is nuclear fusion in just 5 minutes. So thank you very much for the clarification and the enlightenment that you have provided to us. And now, relating to one of the things that you mentioned before, and taking into consideration that we're here in a Congress on decarbonization and renewable energies also, I would like to ask you, Yassid, another question, and that would be in our fight now against climate change, how do nuclear fusion technologies, how do they interact? Either they compete or they cooperate with other renewable energy sources. How do they intermingle between them? And how would this affect the energy landscape here at the European Union level?
Hello, I hope that you can hear me.
Yes.
I would like to thank the organizer for inviting me to speak here, and with such high-profile speakers too. And unfortunately, I was not able to travel there to meet you in person because of last time problems. And well, I'd like to answer your question, and will resonate somewhat in what Ángel already introduced, because it's very well aligned with the problematic. And I think that's the best way to introduce the answer to this question would be that there is a German word that describes this very well, which is, excuse me for my poor German, but it's Dunkelflot. And it kind of describes weather that is cloudy and lack of wind. So the kind of conditions that would make a renewable power production kind of vulnerable, reducing it, of course. So Germany is currently experiencing a prolonged spell with stark consequences for the country itself and the European neighbors, just because of some reasons, including political ones. Germany decided to abandon nuclear power plants. And as you know, this was highlighted in the headlines last week, because the increase on electricity production because of these conditions really spiked, going to the cost of a megawatt to something like about 1,000 euros, which is a record. Just to compare, in Spain, the price is about 100 euros per megawatt. So in general, of course, one can think that a country like Germany, the energy system is flexible to adapt to the demands and the production by renewable energies and other sources, like could be, fossil fuels, of course. But in November, for example, I just put some numbers here to illustrate what's the problematic, is that the power production based on renewable energy was only about 4%, which is quite low. And of course, everything becomes more complicated since the war in Ukraine, because Germany was exporting cheap gas from Russia, and that was completely cut. So now they have to rely once again on, let's call it dirty fossil fuel, which is the carbon. So it was 30% produced by carbon. So of course, with these numbers, you can imagine that what we have right now in hands in terms of fusion development is really important to complement all these scenarios. So there's, of course, many things that have been introduced by Ángel, and I think that besides being a complementary power source, there's quite a lot of benefits compared to the other renewable energies, because it's constant, right? It provides constant power generation, and it's not intermittent. And that would help to stabilize the whole grid in Europe. There is zero emissions, well, almost zero emissions, let's say, which aligns pretty well with the decarbonization goals. And as it was said before, there's also a minimal radioactive waste compared to nuclear fission, where you produce quite a lot of waste. And as Ángel also mentioned, there is a high energy density, and that it's very advantageous because in principle, the areas where, the space that you need for the facilities and installation it's smaller than what you need for a power plant. And of course, there's political implications in terms of energy security, because that, in principle, as was said before, the materials needed to produce fusion are abundant, and of course, that will reduce the European Union geopolitical dependence, as I was pointing out before. Of course, there's quite a lot of challenges, and well, you know that this is a long-term, let's say this is still in experimental phase, and well, we still need several years to see the first commercial station, and of course, the investment is quite less in that regard. So there's some objectives in the European Union regarding the energy system, and well, the European Union has set an ambitious goal for renewable energies, which will be 20% of the total consumption that has been already exceeded. So, and of course, one also has to take into account that there is a report that indicates that the potential of wind energy is higher than expected electricity in demand in Europe, and it will be even larger by 2030.
Thank you very much, Yassid. And you've mentioned several topics here that I think that will be related to the next question that I'm gonna pose to you, Lorenzo. And in a more general perspective, and considering the context of climate change and energy insecurity that we are facing at the moment, how is nuclear fusion positioned at the moment as a practical midterm solution? And what would be the impact of its implementation in terms of energetic autonomy at the European Union level? How this is perceived in a more general perspective? What can you say to us from, let's say, a policy-oriented perspective? Excuse me, Lorenzo, we seem not to hear you. I don't know if you're muted or your computer is muted at the moment. I think now you're muted now, so we should be hearing you. Just give us a brief second, and we're gonna check technically if there's anything that is any issue, and if we cannot fix it now, what we can do is just we can skip this question and see if we can fix the technical problem we have with Lorenzo, and now we can just move back to Ángel, and Ángel, I would like to ask you about also a very hot topic, which is the commercialization of nuclear fusion energy. We know that this is a long-term goal, and this is a long-term objective that we have, but on the way, there are a lot of advancement, there are a lot of technology that's been produced by the research. And I think it is important to highlight how this research and how these advancements can be used by other sectors and by other technologies. Technologies and sectors that can really benefit from nuclear fusion development and research. So how do you see this situation, and how the startups and the entrepreneurial environment of these other sectors can benefit from the research that you are conducting in the nuclear fusion sector?
Okay, well, you already said right now, I mean, it is clear that in the development of big projects, not only fusion, but this happens with other big facilities also, but especially in the case of fusion research in the last decades, it is needed to develop a lot of technologies to, let's say, over the limits that you know at this moment in time. And due to this, a lot of new developments are needed. These developments can be, of course, be used in other technology areas, and at the end, they came to the economical sector. In the case of fusion, there is a very obvious or very significant example. I mean, that is magnetic technology. The fusion requires the construction of the biggest magnets in the world in different aspects, superconducting magnets usually, not only high temperature superconductors, but also normal temperature superconductors. And this has been an area that has been developed a lot in the last decades due to the fusion requirements, due to accelerator technology requirements, but mainly fusion. And this has very significant consequences in the development of diagnostic machines that there are, as you know, there are a lot of them that requires significant magnet technologies. I think that fusion has a very important impact in the development of these technologies. There are other examples also, like some different type of materials that have been developed, heating systems, microwave sources. These kind of things has been developed a lot in the fusion due to the fusion requirements and in the fusion community, and these are having also impacts in the in other economical sectors. I would like also to make another comment that I fully agree with what you said about long term for the commercialization of fusion energy, but I must say that this is not fully the understanding in the full community at this moment in time. You know, and I want to link this with the mention that you made about the startups. In the last few years, it is happening a very significant movement in the fusion ecosystem. That is that private money is coming into the fusion ecosystem in a significant amount, and a number we are talking about around 8,000 million euros in the last 5 years going to private companies with usually startups trying to develop faster approaches for the development of fusion. In fact, there are some companies that say that they plan to produce energy in a time frame of 5 to 10 years. I do not think this is realistic, but it is something that is happening, and a lot of effort is going in this area. The main advantages of these startups is that compared with the, let's say, with the public system, is that the management of the risk is completely different in these companies. It is assumed that many of them will fail, but maybe 1 or 2 will be able to succeed. And also the second important aspect of this, of the fact that a lot of these companies are coming up, is that they are the effect is that they are diversifying a lot the different approaches to the different problems of fusion, or the fusion energy production. And maybe some of these, let's say, non-standard approaches can be successful and produce some results. It is true that the problems, the technical or technological problems to build a fusion reactor, they are still there, but the fact that the private money is coming to private companies to work in fusion is a game changer in our environment, and it can have significant impact in the next decade or something like this.
Thank you very much, Ángel. And I think it's quite important to take into consideration one of the things that you've said on the first part of your speech, and the importance of technology transfer in the sectors, and how the knowledge transfer that can be conducted between sectors, and how all of them can benefit, especially in terms of promoting the uptake of startup or entrepreneurial initiatives. And just linking with the last conversation that we were having with Ángel, I think that it is nice here to present to you a success story in the field of nuclear fusion, and we have a representative of it, Yassid. I think that you've been member of the Neutron Insight initiative as a very successful spin-off that has successfully managed to combine disruptive technologies with very agile business models. And I would like you to give us a bit of an explanation, or what is your perspective on this initiative of yours and how it can be used as a, let's say, as an inspiration for other startups in terms of producing disruptive technology and at the same time attracting investment in this context, which, as we all know, is a very complex market.
So, yeah, so once again, I think that what I'm going to say will resonate with the previous intervention. And I would say that Neutron Insight is kind of like a new spin-off company that can be framed within this fusion ecosystem. We do not work with, well, in the terms of power generation, but neutrons. So neutrons are an important part of fusion generation and also material science. So Neutron Insight was born with the idea of transferring knowledge directly to society, of course, which is, in my opinion, one of the goals that any scientist should pursue. That's my opinion, of course. But this project was created from fundamental research in applied nuclear physics, and in this particular case, something completely different, detection and imaging of neutrons in the production of radioactive isotopes. So there are, and as well known, that there are certain applications where nuclear physics is well categorized and framed, which is energy, and medical and industrial applications, among many other things, of course. There are great barriers and challenges coming from, of course, ignorance, and why not to say that it's the fear that revolves around words like radioactivity and nuclear. So in general, there's still a long way to go to normalize and explode use, given that in this environment, everything is subject to very strong regulations and very complex technological challenges. And another major challenge is to attract qualified personnel, especially in a country like Spain, where there is not a sufficient, let's say, widespread nuclear culture, if you're allowed to say that, as is in the case of the United States, which is very well normalized. If we take a look to where that origin comes of the knowledge, it is acquired and promoted, well, in general physics, in nuclear physics in general, has been always more in favor of high energy physics, as you know. And it's also true that most of the technology that we use in our field nowadays is inherited from big experiments, like the large experiments at CERN, that you know. And today it's common to see how a large percentage of young researchers are more oriented to theoretical and fundamental physics than applied physics. So for me, that has been a barrier. And of course, I mean, if you go out there to the street, it's easier to find someone who knows what's CERN than someone who knows what the European Spallation Source is, or DONES, for example. So the other problem is, of course, raising investment. That has been always a circular problem and a complicated exercise because the lack of a well-established market for these technologies, of course. I mean, it is circular because it's complicated to raise a significant amount of money through private investment without having a solid product, an MVP, which is usually financed by your research fund. So this is why I call circular. Obviously, everything that revolves around fusion and power generation has more a solid market, or at least in the future, as we are discussing. However, taking into account the timelines to reach the effective commercialization of fusion power, it is logical that many of the byproducts of all kinds of research and technology that revolve around this ecosystem of fusion have a high degree of maturity and a potential market. And this is the case of neutrons. In our case, what we do is we are trying to build a portable system of radiography, which is, let's call it like that, a miniaturized version of the experiment that are proposed for studying the impact of neutrons in materials. And just to finalize, after many iterations, we just realized that what the industry wants is to go there and use the technology in situ. So this is what we are developing right now. And for this, it's essential to have right partners, both industrially and scientifically. Part of this, knowing how to approach the customer, it's a huge challenge in this case because it's not really trivial to convince someone that using neutrons have more benefits than using conventional trade.
Thank you, Yassid, and congratulations for your experience and the success story that you were mentioning to us and explaining. And now I think that Lorenzo, we have you back, and you have your voice connection already fixed. Let's give it a try and see if that.
Hello, can you hear me?
Yes, we can hear you, Lorenzo.
That's awesome.
No problem.
So, nice. Thank you, and I'm glad to be here. And well, I was expecting a presentation, but it seems that we have a new format, and we'll see what comes out of this format. And well, first of all, let me say that in the case of Europe, nuclear fusion has been driven by the European community. If you read the Euratom Treaty of 1957, you would see that the study of fusion is inserted there. So for the European Commission, I'm of course a policy officer in the Commission. Fusion has been until now a research activity with a consistent budget that from 2014 until 2025 is of 1.6 billion of euros. Now, the flagship of this program, of the Euratom Research and Training Program, has been Eurofusion, which is a European co-funded partnership, which basically has the objective that Ángel was mentioning before, which, by the way, I want to stress, it's the Eurofusion roadmap, not the European roadmap, and I will explain in a short while why this difference. But the goal is to get to a demonstration power plant that will demonstrate the feasibility of fusion electricity. Now, and also it will support IFMIF-DONES for advanced material in fusion, and of course the creation of skills. So we need to create a workforce to work in fusion. Now, what I want to say that is that basically there is in the late year we try to open up to the private sector, and this was mirrored in several official documents of the Commission, but still which intend that fusion may be a tool to diversify the European energy mix. However, fusion is not producing electricity today. And so, for example, in the Net Zero Industry Act, you may read that fusion was inserted in the first proposal, but then the final version that was agreed with the Parliament does include fusion directly, but it indicates relevant nuclear technology. But still, the attention towards fusion is increasing in the European political world. You can simply read Mario Draghi's report on competitiveness, which I guess was on the newspaper for a while, 2 months ago. And you will see that fusion is directly mentioned. Also, we are doing many steps ahead to to stress that fusion, for all the reasons that the other two panelists said before, can be regarded, can be intended as a green technology that can help us to achieve climate neutrality. So, for example, you will see that nuclear in general has been inserted in the taxonomy for zero and low carbon technologies, and also there was a official Commission communication in February this year that actually stressed that nuclear is one of the solutions to achieve neutrality. That said, okay, so for the moment, the European Commission sees fusion in the future. For the present, we want to engage with the private sector. What Ángel was saying before is true. And worldwide, we are talking about 6.6 billion of euros invested in private startups that actually represent an enormous amount of money. Actually, sorry, 6.6 is the total funding. 95% of this is private though. So we are around the same figure anyway. And to do that, the Commission is moving towards a more comprehensive strategy, which is a European fusion strategy that is being defined and is being discussed with member states, but you already can see the effects. And the first one is that we launched the European instrument called Coordination and Support Action, which should create in 2025 a European fusion industry platform. This will be aimed at both the, so to say, large industry and the startups. And what we want to do with this is to launch a public-private partnership, but also to create an agenda for fusion development. So that is one example. And what I want to say is that actually there are already opportunities in this field, but I guess you'll have, how to say, a later question for me on this.
Okay, thank you, Lorenzo. I think that unfortunately, as with every interesting conversation, we're running out of time. Again, that usually happens when I moderate a roundtable. I don't know how I do it, and I promise that I try to speak the less. And even though it still happens. So I just wanted to pose you a last question, Lorenzo, and then I think that we must call it today with the roundtable, and it's about regulatory certainty, because some of the comments that we've received here from Ángel and Yassid and yourself are about some critiques about the waste generated in nuclear fusion production, the need to train somehow professionals in the sector to promote the development of startups and entrepreneurial initiatives within the sector. How do you think that more regulatory certainty among the general public would benefit, would make, let's say, even change the perception among the general public of nuclear fusion and proceed as a potential solution and a really feasible solution? And that would be my last question.
Oh, that is a very interesting question. So let me follow up on what I said before, because I really want to tell the people participating in this conference that there will be opportunities for startups. We foresee an innovation pillar in cooperation with the European Innovation Council for 2026, by 2026. And this will provide funding for startups who want to invest in fusion innovation. Furthermore, we, of course, we will open up the European Fusion Industry Platform to all large industry and startups. And we do that to draft a strategic research agenda on fusion energy. So this will also be an opportunity. Furthermore, I guess the representative of the technology transfer activities of Eurofusion are among you. So there are already opportunities in that sense. But regarding the specific question you have said, so regulatory frameworks are essential. The view of the Commission is if we provide clear rules, clear regulatory framework, then we can, how to say, encourage startups or companies to invest in fusion. To do that, first, we need to move away from the present situation. The present situation is that we use the same regulatory framework that we use for fission startup, for, so to say, traditional nuclear. and we use this one also for what will be fusion. So the first step is to develop a new framework with new observation, just to say that while many safety principles apply of fusion energy apply, the hazard potential of fusion is significantly lower, and this could reflect in a graded approach, proportionality, that will allow us to give less constraint or to tailor new regulatory frameworks. Of course, to do that, if you know how to work, how nuclear works in Europe, you know we need to harmonize this, coordinate with member state. That's exactly what we are doing through the Fusion Expert Group, which is a group intended to bring together European member states and discuss, but we can also use the lesson learned from ITER, since the licensing process of ITER already provided insights, and of course can help to understand how to progressively tailor to structure the regulatory framework to the needs of fusion energy. So what does it mean? It means more opportunities for industry. For example, the need to adapt existing code and start to fusion-specific requirement. It means that through effective communication, we can actually try to give a unitary view of what this is. For example, in the case of fuel, as Ángel was saying, actually, according to the study I've read, there is the possibility to reduce of 90% the most sensitive waste through some kind of through specific treatments, and this could also be a sector of investment, of course, when it comes. And this is exactly, I believe, how we can do that. So through providing opportunities for the industry and through creating, for example, educational path, we can actually make fusion more, more interesting, not only for member states, but also for European citizens.
Okay, thank you very much. It was very enlightening. I think that we're, as I was saying before, we're running out of time, but we're really grateful for your contributions. I think that they have been very inspiring, and I encourage the audience to seize the opportunity posed by nuclear fusion and to contribute actively to its development and adoption, which I think is the task for all of us convened here. So thank you very much, Ángel, Yassid, and Lorenzo. Thank you very much, and have a good holiday season. Bye-bye.
Thank you very much to you.
Thank you. Bye-bye.